Hi, welcome back to the insanity. So, today we're gonna talk about salvaging parts off old components that are no longer of any value. I mean, they were once things and they broke, or for whatever reason they became of no value and they got put in a bag or a box or a tote somewhere, and they sat there for a while until I didn't need any parts off of them or whatever, and I needed to make more space for more broken things. So what I do is I go through and I remove pretty much all the parts, or any of the parts, and I put them in a little container, put them in some bags and whatnot, and save them up for projects, various things. Now, a lot of these parts aren't things that I'll be using. Actually, there might be some things on it looks like memory. These look like memory chips. Who knows? Maybe I can use them for an Arduino project or some crazy thing. Who knows? I don't know. But there are many other parts on here, capacitors, diodes, all these good things. And this board is got a bunch of through-hole components, and I thought it would be good to do that. It's also a single-sided board, so there's some. See how things are different. This is a 4-sided. This is a nice 4-layer, probably, circuit board. This is a pretty good quality circuit board too. Probably 4 layers. This one's pretty low grade, but whatever, doesn't matter. We're going to be getting sweet juicy parts. This is about getting sweet juicy parts, and we could destroy the PCB getting those parts, but we don't actually have to. So we're going to do that just by heating it up, mostly using soldering irons and other tools. Some of the parts may not be worth getting, just too much trouble, you know. But I'll try to show you several different examples of how to remove some of these sweet juicy parts. And here's an example of, this is basically a 3.3 volt buck converter. It bucks like 12 volts or whatever. In this case, it normally gets 12 volts in a connector that's already been removed from this board here. There's a 12 volt DC plug-in, plugs into here, and it makes 3.3 volts with some components here. And basically, I found the voltage regulator and checked it out, and found a example circuit, and found, when I looked at the circuit, I looked around and I found pretty much all the parts that I need for the example circuit right around it. So I went ahead and removed those parts and built that circuit out of that, and sure enough, I put 12 volts in and I get 3.3 volts out, and I can run nifty little microcontrollers on 3.3 volts, and so I'm happy, yeah. So I should probably start by salvaging some of these guys here, and I could use my fancy brand new soldering iron, but to show you that you don't really have to have any special tools, I'm going to do it all with this crappy old soldering iron. In fact, I got 2 crappy old soldering irons. Sword fighting. So, we'll remove some parts, set them aside, organize them, group them, so that you can find them later and make something of value of them, because we're turning trash into treasure. Alrighty, so normally when I disassemble a board, I like to take the bigger chunks off first and then get down to the smaller things. Sort of the reverse order of building a circuit board. Build it the smallest things and then the biggest things, because when you build the bigger things, it's hard to get to the smaller things. So it makes sense it reverses somewhere. But in this case, I'm going to start with these through-hole parts. I think we'll take all the conductors too. Why not? And this guy here will be an interesting one. So, let's get going. Okay, when you're applying the soldering iron, try not to push into the board too hard. I was doing that a little bit there. Okay, now that I got all 4 of those leads, or all 5 of those leads lifted up, the base of that part there is really what's holding it on. That's a nice glare right there in the middle, isn't it? What to do about that? Okay, so this is a 25-watt soldering iron, and this part I'm putting it on is a TO220. It's like huge, ginormous, and so it's going to take a long time for this little iron here to heat up this big ol' heat sink on this part here, but it will. Hey, you know what makes it heat up faster than one soldering iron? 2 soldering irons. Also, I added a bunch of solder there for 2 reasons. One, to add to the thermal mass of the hotness, basically more area of hot, but also to, and more importantly, to help thermal conductivity, to get the hot from the tip of the iron onto the part. What really helps do that is that solder there helps transfer the heat from the soldering iron to the part. Hope this comes off before I push it off the screen. There we go. Now it's off. That was probably one of the more difficult parts on this to get off because it does have such a huge plane. Look at that. This iron doesn't do a very good job of getting that. Barely smelts it. Yeah. So the traces here. I just like to smooth them out. Don't have to. And we have harvested this here sweet juicy part, which is warm enough, but I'll set it aside for now. Man, that glare right in the middle there sucks. Gotta do something about that. Okay, so with two soldering irons, we can pull this diode off really quick, like that. But if you only have one soldering iron, we'll set him aside there too. If you only have one soldering iron, you can still do that. There's another diode over here. You can still do it by heating one side and lifting the part. And then heat this side, whoop, and it pops right off. Easy peasy. So there we are. And what other parts should we need? Let's go ahead and take this off of here because it's annoying. It's annoying me. It's no longer there. Now, get these parts off. Okay. So what I've done here is I've isolated the leads for the coil, one side of the board and on this side of the board. And I heat one lead. That lead is actually connected to a whole bunch of ground plane, isn't it? Yeah, it's hard to tell, but also I need to put a little bit of solder on the tip here. That helps that thermal conductivity, makes that heat go from the iron into the solder joint. Yeah, these 30-watt soldering irons are punishment. Okay, I got that one side out pretty easy. The other side is soldered to a whole lot of ground plane, but it's making it difficult. We might see if we can get it from the top side. It's going to take 2 irons. Getting that hot melt on it, I hate that. I don't know why that was such a pain in the butt to get out. But I did get it out. There we are. Inductors have big leads on one side on the ground. Also, capacitors, these are probably also going to be a pain in the butt because one side will go to ground. See that? That pin there will be very difficult. No, they're not so bad. So I heated that and then pushed the cap over just a smidge by tilting it. I'm going to heat up this, but I'm not expecting that's going to come loose too easy. When it does, I'm going to rock it the opposite way and hopefully out. That lead out, not the whole cap out, but hopefully you can get that lead out. Also, this is a electrolytic cap. You don't want to force it. You gotta be careful not to force it if you're trying to save the part. There's a way to get 2 soldering irons on it. I think that came out some. Heat the other side and try to rock it the other way again. Ah, I got it out. There you are. And we'll try again. This time, I'll add a little bit more solder. That's this one here. Because having that extra thermal mass really helps transfer the heat. Oh, I think it was the other side that was connected to ground. This side ain't moving. Maybe. Okay, I gotta move some. Now let's see if I can heat the other side. It's almost, come on, I can feel it, it's getting a little looser. Come on. And it's getting hot too. It's a little hard to hold. Come on, baby. Whew, God, that took a lot. Alrighty, so got that one out too. So it is kind of ugly, but parts are out. There's a couple of more through-hole parts here that I think I'll go ahead and get while I'm out, just because. Okay, so I heated one side. Then I fold the part up, not entirely out all the way, but most of the way up. Now I'll go ahead and heat up the other part, and the other part seems to be hooked up to a bit of ground. That might take a bit to get her going there. Alright. Pull that side out. Now, heat this side up again. There we are. It's a little ugly. Clamp the leads. And that'll be okay. A couple more inductors over here. There's a considerable trace up on this side of the board. Alrighty. One left. It's out on that side. Okay, pulled that guy out too. Alrighty, so that's considerably cleaned up that corner of the board. There's some really large connectors here. Oh, maybe I should take off this switch too. Hey, that might go faster with the 2 irons, but I suppose I should show you with 1. Okay, so got my tweezers in there. Between the part and the board. And heat the leads up on one side. This thing's pretty well heated up. Kind of difficult to get the part. Okay, so now I'm going to let that cool. Stick my tweezers on the other side of the part. Put in a little bit of solder. Put that on there. So on both leads at one time. Got it out on that side. Now reheat the first 2 holes. And out. Clean up the leads. Whoop. Drop it on the floor. Voila. Fresh, juicy parts for your next project. These guys have huge blobs. I think I even tried to solder these. I don't know, maybe that's from when they were soldered on. But with these 30-watt soldering irons, these huge solder joints on these huge things, just not likely to happen. They might even be something I'd cut off, although I'll probably try hot air on those. It would be nice to get it out of there because this is just kind of annoying. So these are this pile of parts I salvaged, and most of them are going to be used for making a little buck converter like this. No big whoop. Some parts, some wires, a little perp board, and you've got something that'll run 3.3 volts from whatever you throw in it. And I like that. Now, so that was kind of an example of some through hole. Let's go ahead and continue and pull off these LEDs. I bet these LEDs will come off pretty quick. And this isn't a really hot iron. With a hotter iron, this is way quicker. Okay. Boop. That one's out. And one thing you can do, and you can also use this technique for soldering, is you can preheat the next solder joint you're working on by holding the iron behind it. So as I'm heating up the joints with the tip, the part behind the tip there is heating up the next solder joint. If I was holding it facing the other way, it wouldn't do that. So in general, when you can hold the soldering iron in a way that it preheats the next solder joint you're working on, that'll help you. Come on. Really helps to get an extra bit of solder on there. Mostly for the thermal conductivity, actually making contact with the parts that you want to get hot, but also adds a little bit of thermal mass. It's sort of like having a little bit bigger of a soldering iron, which helps out, particularly when you got a little itty bitty soldering iron. 25 watts is about as pathetic as it gets. Whatever you got's gonna be better. So these are panel mount LEDs. They got a nice little 90-degree angle on them. And a little holder to hold the LED at a nice angle. Come on. Add a little solder. Yeah, baby, you can do it. You can do it. You can do it. Come on. See, you kind of wiggling. See, you're trying to come out. Come on. Come along now. There we are. You know, last one was difficult. I don't know.